Hello learner, once again. Welcome to Manifested Online Classes. My name is James Kenyani. We are yet again going to start a new topic by the name Area Approximation. And before we go further, in book 1, we learned a method of finding area of irregular shapes by counting method. In this topic, we shall yet again get to know other methods of finding area of irregular shapes. So the objectives are outlined as here. By the end of the lesson, the learner should be able to approximate area of irregular shapes by counting technique. Derive trapezium rule. Apply trapezium rule to approximate area of irregular shapes. Apply trapezium rule to approximate area under a curve. Derive what we call the mid-ordinate rule. Apply the same rule to calculate area under a curve. But for this lesson, we are not going to bite all that. We have started to bite little by little. So in our lesson today, we shall learn about finding area of irregular shapes by counting method. That doesn't end there. Why are we having this? Some of you could be having a shamba, and on the edge of the shamba there is a river, like some of the diagrams drawn there. This could be a river bordering that shaded shamba, or this could be a shamba there. It doesn't have a uniform boundary. So in this lesson, we are going to learn how to do that. So the objective is simply as hard. So it does not end there. So the objective is to enable the learner to find area of irregular shapes and apply the technique in finding area on actual ground. What we are seeing is a representation. So the learner at this stage should know area. The learner in red. So you should know that that area can be found by counting squares, trapezium rule, or what we call mid-ordinate rule. But in this lesson, we are dwelling on the counting method or counting squares. Counting squares. So our interest will not be trapezium or mid-ordinate rule. We are only going to dwell on counting method. So we get an example. Find the area in figure A in square units by counting squares. So as the lesson goes, it is trying to help us to get the area when the boundary is irregular. When the boundary is irregular. These are the square units, 1, 2, like that. So you find in counting square method, we count full squares, we count full squares, then we add to the half squares. So whether that square is not exactly a half, like this and this, we shall count it as a half square. Like this one is a half square, a half square, a half square, a half square, half square. We should just give it a half square. This is a half square, half square, half square, half square, half square. So what you'll do, you'll know that area will be equal to area of full squares plus area of half squares. So I'll go there, I'll mark these. If you see that, that is a half square. And if you see a dot, that is a full square, a full square. Full square. So after getting the half squares, I'll multiply by a half because they are not full squares. So let's go. Let's start by the full squares. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, Lana, 12, 13. We just repeat again because of visually seeing them. Full squares, let's count. 1, 2. This one is not full because of that. So 1, 2, 3, 4, 5, 6, 7. So this will not be counted as full because it is not exactly full. So we repeat 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are how many full squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So we have 33 square units, not as 30. So we have 33. So when you are getting the area, you'll come, area of the full squares is, there are 12 of them, plus, since these ones are a half, you'll take a half times 31. That will give you 12 plus 15 and a half. Lana, that will give you 27 and a half square units. 27 and a half square units. I've got that area, but that doesn't end there. That doesn't end there. So if this is 1, they can still talk of 2. We can still talk of question 2 under the same. That was 1. In 2, they can ask if in figure A, one side of the square unit represents 100 meters on ground. So find the area in the area of the land in hectares. In hectares. So what they are saying, Lana, they are saying if this represents 100 meters, this will also represent 100 meters. 100 meters. So the solution for that area in hectares will be equal to area number of square units. Number of square units times actual area of it, area of each unit. Then you divide by 10,000. Why do you divide by 10,000? It is because 1 hectare is 10,000 square meters. Is 10,000 square meters. So the number of units we found were 27 and a half. It will be 27.5. Each square unit, I'm talking about these, because they said one side is 100, the other one is 100. So the area of each is 100 meters times 100 meters. So I'll divide by 10,000 meters squared, which is equivalent to 1 hectare. So those zeros, you'll find them cancelling out. The meter squared with the meter squared. So I'll get 27.5 hectares. So you see, we've gone a notch higher by applying what we've learned to get the area. So number 2, in figure 2b, find the area in the area by counting squares. Find the area by counting squares. So what you'll do, we shall just use the same method we used in the first figure, Lana. Use the first lesson. So you shall come here and just say x for half square and dot for full square, for full square. So without wasting time, I go to the full squares. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14. 14, this is a half square. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 28, and 29. You can repeat to confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So for full square, you get 29. You move to half squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Can repeat again. 1, there's one we missed here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So half squares, 15. So total area, just come total area, will be given by full squares plus half squares. That is what we do when we have the counting squares. So the full squares are 29 lana. They are 29, and the half squares you'll multiply by half times 15. This will work to 29 plus 7.5. This will give you 36.5 square units. You say units because this is just a unit. So having worked that, having gone through that learner, you've seen how to count. However, as small the half box is, you take it as a half because they balance. Some are big and some are small. So the averages bring them to the center. So for the assignment, so Lana, those are the questions related to our figures. Find the actual area in hectares in figure B if one side of the square unit represents 50 meters on ground. And number 2, find the actual area of the figure in A if one square unit represents 200 meters on ground. Having reached there, learner, you'll get a good experience of that and of what we've learned in counting squares. Whether a square is small, count it as half. Whether a half square is so small, tiny, count it as half. So at that juncture, I hope you'll go keenly through the exercise before we meet in the next lesson. So thank you. Have a nice time. Enjoy your assignment. Let's meet in the next lesson with agility, with the same agility to continue. Bye-bye.